Okay, so today 10.2. So inference about before we talk a large sample. Today is a small sample. Okay, same independent sample. This time only one thing is different. Small sample and two things I think equal standard deviation. Okay, before we have a standard deviation given, the known or unknown, but in this case using equal. There's difference. Alright, so with what we're gonna talk about this section. First of all, how to make a confidence interval. Because this question, confidence interval. So today we deal with the confidence interval, and next time we talk about hypothesis test. Alright, so confidence interval. So difference between two population mean when they have a small sample. Okay, remember last time we had large sample, we talked about greater equal than 30. So small sample means less than 30, both population and independent. Okay, large, small doesn't matter. This should be independent and normal distribution. So small value, small also. We talk about sample size small, but we need to confirm or make sure independent. And then assume we have two assumption. First assumption will be normal distribution. Okay, so sample to sample approximately normal distribution. Okay, and second assumption, standard deviation to population what equal. Okay, that's difference. Should be equal. So which means two unknown, which means 2 sigma, two population of standard deviation of each two population. So sigma 1, sigma 2 unknown. That time we say just equal. Okay, so in this case it's not equal. We're talking about next section. All right, not today. So anyway, we should confirm or should make sure small size, small sample, independent, and normal distribution, and two standard deviation what equal. Okay. All right. So now, if you satisfy this condition, we're gonna use T distribution, right? Do you remember that? Large sample G distribution, but small sample T distribution. I think we already talking about chapter 8, right? Before about sigma 1 to sigma 2 and mu 1, mu 2 for small and independent sample. Okay, move on. So one more time, when to use T distribution? I mentioned it before, right? Just write down one more time. So T distribution used to make inference of a mu 1 subtract mu 2. So we assumption hold true. Which one is first one? Normal distribution, most important, right? Normal distribution. Okay, to sample, target sample, and here small sample size and independent. Okay, normal distribution, small, independent, and one more what? If you 2 sigma, which is a standard deviation for population unknown, that time we say what? 2 sigma 1 2 will be equal. Alright, if you satisfy that condition, we're gonna using what? T distribution. Okay. Alright, so there are the name full standard deviation for 2 sample, but before that we're gonna little bit explain. I mentioned it before, standard deviation for 2 population equal like that. So just mu and sigma maybe the same like here, because it's same number. So sigma 1 and 2 equal, let's say just sigma. Okay, so sigma is unknown, so that time we're gonna using like S subscript P, like SP, point estimator. That call name full standard deviation. Okay, full sample standard deviation. So SP will be what? Full sample standard deviation. That's why P here, right? Well, subscript P is okay. Anyway, so SP, we're gonna use SP, right? S means sample, P means full sample standard deviation. That means what? What's the standard deviation or unknown, alright? Okay, so compute, how can I calculation? This part, you should memorize that. Memorize, okay? So, standard deviation for, like full sample standard deviation, square root, n minus 1 minus 1, and 2 minus 1, as each standard deviation for sample, right? So S1, S2, and the n minus 1 is 2. Can you see the n minus 1 is 2? Alright, so next one probably explain more. Okay, n1 and 2, we know sample size. Okay, S1, 2 sample for standard deviation, for sample, without keep say sample. So SP, which one is estimated for sigma. Sigma is, we say, equal. Sigma 1, 2, so it doesn't matter. So 2 population, so we're going to use SP. So more, n minus 1 means what? Degree of freedom. N minus 2 minus 1, and 2 minus 1, sorry. Degree of freedom, sample 2. Okay? At the bottom, what is that? N1 plus N2 minus 2. This degree of freedom, 2 sample take together. Because we have together, right? If you one, only 1, subtract 1. The 2, so subtract 2. Okay? Formula. Right, okay. So before we have formula, remember, like S, like square root, S square 1 and 1, S 2 square and 2, right? That one. This for standard deviation, but it's different because it's a full sample. Why? They said equal, alright? Satisfies 3 conditions: small, independent, and normal. And then if you sigma equal, that time using SP. Okay, so SP is estimator standard deviation here. Okay, so for sample, so we're gonna use here SPI. Okay, all right. So how we can estimate for standard deviation sample? So using here. Okay, like that. Okay, for that time using S, because sigma same, so S1, S2 also same. So we using here. So which means S equal S1, S2 same, equal, not equal, right? Okay, read around here. Sorry, maybe make it clear. Little understood better. Alright. Alright. S1 like S2. This one we using that we say SP. Okay. Got it? Alright. Alright. So one more. So when you make confidence interval, but test a hypothesis later anyway about mu1, mu2. So we should be small, independent, and unknown standard deviation, and one more normal distribution anyway. Okay. Alright, maybe. And get into problem. Before problem, one more explain for in confidence interval. How can you estimate for that? So confidence interval for mu1, mu2, we can find the difference between mean to population. So difference between sample mean is point estimator for population mean. Okay, we already know, right? Maybe here is the mu, right? This will call, we say, point estimator. We already know that, right? Only here's two population. That's different, but looks like same. Alright, so confidence interval mu1 subtract mu2 when t distribution using small sample. So we already know when you're using small sample, t distribution, large sample, z distribution. Alright. Okay, so how can you find the confidence interval? mu1, mu2. So significant level they given. So we can using here. How we can do that? Do you remember the formula? Right? Before large sample, we only different this part, right? Large sample, we can do that like a z sigma or s depend on, right? 1 s2, right? So this for large sample, this small sample using t. Okay. So we have here value t. How can obtain from normal distribution table? Yeah. Sorry, normal from normal distribution table. No, t distribution table. Sorry, this t table given confidence interval. So this one degree of freedom. Okay. So t distribution table. Okay. So where? Remember I mentioned before, like that, like that. So as here for sigma, standard deviation for sample using this formula, and SP from using here. So find that and that find here. Little more complicated, right? Alright. So maybe try one example today for confidence interval. Okay, confidence interval. The last problem for mu1, mu2. So make sure a small, independent, and standard deviation should be same, right? Which means unknown. Alright, what's the question? Okay, consumer agency wanted to estimate difference the mean amount of caffeine in two brand coffee. Okay, they're gonna compare two brand coffee. So there's the first one, 15 sample, brand 1, and the mean will be 80 milligram. Standard deviation 5. Okay. Second sample, 12 sample, brand 2. So this one mean will be 77, standard deviation and 6. And significant level 95% confidence interval. And this assume the normal distribution, yes. And equal means unknown. Okay. Alright. So how we can approach? First of all, we should decide what's the mu1. Mu is brand 1. Brand 1 about coffee, right? Mean amount of caffeine for jar in all for pound jar. Anyway, the brand 1. The mu2, brand 2. Okay. And the x1, x2 for sample, the mean over respect to sample. Okay. So getting information together, okay, we have brand 1, brand 2. So each of our sample size and sample mean and standard deviation of a sample. Alright. And one more, if you hear x1, x2 will be 3. Will be point estimator mu1, mu2. Right? So one more time, right? So we know mu x bar. We say before this one point estimator, right? Same idea. Alright, getting problem. So there's data from previous slides, right? This information. But we should find 95% confidence interval in this case. Full difference between the mean, okay? Two sample, like brand 1, brand 2. Alright, so confidence interval, they say 95%, okay? And standard deviation, calculation part, a little hard. But looks complex, we understand that, right? SP, using square root, first sample minus 1, first n standard deviation for sample S1, and second sample minus 1, and sample second sample standard deviation S2, and first sample, second sample minus 2, right? Calculation part, we come with this number, and we are looking for standard deviation for sample, right? This one full sample, right? This one sample standard deviation using SP. This is formula and plug in there. So I think you should memorize that, this formula. Unfortunately, sorry about that. Alright, so the tail. So this number, because 95% divided to this number. So this area and degree of freedom, 25. And we look at the t distribution. We got the t value standing at degree of freedom 25.05 area right tail. So t value 2.060. Okay, from the table. So code and obtain. We're trying to make conclusion. 95 confidence interval mu1 mu2. So using this formula. Okay. So one more time. T is small, right? Z is large, and S is small. Sample, right? Sample for sample. This number from this data. Okay. 80 subtract 7, and this number from here to point here. T value, right? And this one by calculation. And calculation. Wow, looks complicated, but step by step, but not hard, just complicated. Takes a while. Alright, so looks like a negative number here. So our conclusion is 95 confidence interval, right? We can state the difference mean amount caffeine, right? And the two brand coffee between 1.36 and 7.36 milligram. Okay, that's our conclusion. So maybe if you understand, you can try. So because of lower limit, interval is negative here, negative 1.36. It's possible the mean amount caffeine greater second brand than first brand. Okay, amount, right? More. So right. Okay, so today we talk about confidence interval. So we're gonna should deal with the confidence interval and hypothesis test. Alright. Next video we're gonna talk about same small independent sample and equal standard deviation for more hypothesis test. Alright. Alright. See you next time. Bye bye. Thank you.